I'll take a look at two more examples of some integrals. So here I have 3 cosine x over 1 plus sine squared x. Now, anything that you've learned in your mathematical career is fair game. So if you are able to do substitutions in some manner, trig substitutions, absolutely go ahead and do them. If you don't know how to do them, then that's perfectly fine. But you might need them at some point is the only way to progress. So here, think about, okay, 1 plus sine squared, does that equal anything? It does not. 1 minus sine squared is equal to cosine squared. So here we have to come up with something else. So what I can do is I could let u be equal to sine x. Then du is going to be equal to cosine x dx. Now that is perfect. I have something to substitute in for this sine x, and I have something to substitute in for cosine x dx. So this is a good choice of u substitution. So this is going to be the integral. Pull out the 3. Integral of 1 over 1 plus u squared du. This integral is now arctan. So I have 3 times arctan of u plus c, but that's just 3 times arctan of u, which was sine x plus c. You can always check your answer if you want, take the derivative, and get that back. Okay. This last one here, x over 1 plus x squared dx. The reason why arctan gets used all the time is because it is so misleading. Because when you look at an integral of 1 over 1 plus x squared dx, this does not scream inverse trig function, right? This screams what powers of x's, or what do I have to do with x's to be able to get this? It's tricky, very tricky. So that's why these are often the hardest integrals to remember, is to make sure that you can use arctan, but arctan doesn't always get used. This looks very similar to this, right? This integral is arctan. This integral will have nothing to do with arctan, even though the top just differs by an x. What this will require us to do is I'm going to let u be equal to the denominator. du is going to be 2x dx. So in other words, I have a 1/2 du is equal to x dx. I substitute this in, I have a 1/2 out front, integral of 1 over u du. So I have 1/2 natural log of the absolute value of u plus c, and this is 1/2 natural log of the absolute value of 1 plus x squared plus c. So integration is one of the hardest things to do in calculus, or even in all of math, because it requires just various techniques, various attempts. You will try, you will fail. I guarantee that if you could look at an integral and know how to solve it every single time perfectly, you probably you wouldn't be here, basically. You would be publishing some types of fancy research papers and stuff. So I expect you to not be able to immediately know how to do every single one of these, but try something, see if it works. If it doesn't, try something again. But it just requires repeated practice over and over and over and over and over again. So keep practicing it, don't get discouraged, and keep trying every technique imaginable with integration. Try to manipulate things. Do whatever you can to be able to integrate, and hopefully when you get to Calc 2, you will have the necessary skills to be able to succeed with all of the integration we're going to do nonstop in that class.